Hello and welcome. My name is Joseph and I will be your tutor for this course. Get ready to get your mind blown as we dive into the world of macros and VBA, which stands for Visual Basics for Applications. This course is basically for novice developers, accountants, financial analysts, project managers, and anyone who wants to learn how to become proficient with Excel VBA and macros. So without much ado, let's get started. Now, what is macro? Macro is a small program or set of actions that is recorded in Microsoft Excel. Excel macros are used to automate repetitive tasks to solve a lot of time and hassle. Macro can be simple or complex depending on the tasks they are assigned to perform. Macros can save you hours of time. You can create macros that do almost anything in Excel and even other Microsoft Office programs. Why must we use macros? Well, macros offer several advantages. Number one is automation. Macros automate repetitive tasks, saving us time and effort. They can perform tasks that would otherwise be tedious and time consuming if done manually. For example, you can create a macro that searches through all of the data in an Excel workbook, compiles the important information, and emails that information through Outlook. And you can do all this with just the click of a button once you make the macro. Number two is efficiency. Macros allow us to execute complex operations with a single click, reducing the chances of human error and improving overall efficiency. And number three is customization. Macros can be customized to meet specific requirements. They give us the flexibility to tailor software applications to our unique needs. In a moment, we will create a simple macro together, but first, let's dive a little into Excel VBA. So what is VBA? VBA stands for Visual Basic for Applications. It is a powerful and versatile programming language that allows us to automate tasks, create custom functions, and interact with various software applications, including Microsoft Office programs like Excel, Word, and PowerPoint. When you run a macro, it is this code that Excel reads to display your actions. VBA is used to write macros, which automate simple and complex tasks in Excel. VBA can be used to analyze a large amount of data, create and maintain complicated financial models. To get started with VBA programming, we need to understand some basic concepts. The first one is called objects. In VBA, everything is considered an object. Excel VBA objects are commands or something that applies in a VBA code to perform some specific tasks. VBA itself is an object-oriented programming language, although not a complete object, but it deals with a project. Objects have properties, methods, and events, and there are basically four primary objects that you would be commonly dealing with. They are application objects, workbook objects, worksheet objects, and range objects. This is an example of worksheet object. This VBA code, when you execute it, it is going to create a new worksheet. Don't bother yourself trying to figure out this code. I'm just using this as an example. In one of the lessons, I covered how to write VBA codes. You will get there. For now, just follow me. Now, this VBA code, what it will do is it will open a new worksheet in the same Excel workbook. So if I execute it, it's going to open a new worksheet for me. Now look at the Excel that I have here. This is a plain Excel workbook and we only have one worksheet here. So when I execute that VBA code, it's going to open a new worksheet for me. And I want that worksheet to have a name called new document. So I'm going to erase this new worksheet. Instead of having it written as new worksheet, I want it to appear as new document. I have written new document, so let's execute the code and see what's going to happen. I will run the code and it has been executed. You can see it's written new document. Let's go back to the Excel worksheet and see for ourselves. Look at it here, new document. Normally it's supposed to show new sheet, but I want it to write new document, and here we have it. You can see our first sheet here, sheet 1, and this is a new document that it opens for us. If I go back to the VBA code and run it again, it's going to open a new document, but it said that name is already taken, try a different one. So I will just have to use a different name, maybe new document 1, then I will execute it, and that's what will happen. You can see new document 1 here. If I go back to our worksheet, it has new document 1 here. Now it opened a new sheet when I execute that first one, but it has sheet 4. But if I wanted to have a specific name, I will have to edit the VBA code to carry that name that I want. So this you are seeing right here is an example of worksheet objects. Like I said before, Excel VBA objects are commands or something that applies in a VBA code to perform some specific tasks. So the purpose of this object is to create a new worksheet. So this is an example of worksheet objects. The second one is procedures. Procedures are blocks of codes that perform specific tasks. In VBA, there are two main types of procedures, which are sub-procedures and function procedures. Sub-procedures do not return a value, while function procedures return a value. Looking at our VBA codes, to create a sub-procedure, you start with the sub keyword followed by the name. Now, this is what we call sub-procedure. So before you start writing your VBA code, you start with the sub keyword, which is this one. So this is it here, sub, and it always ends with this keyword, end sub. So that is how you start and end your code. So when you write the sub, you also follow it by a name. Now the name I gave to this VBA code is open new worksheet. Sub, then the name, and followed by a parenthesis, which is this one we have here. So that is it. Now they have rules on writing the sub. If the procedure performs an action that can be presented with a verb, you can use that verb to name it. House is open new worksheet. You can see it here, open new worksheet. It depends on the function that you want to give it. House is open new worksheet. And number 2 rules is to make the name of the procedure stand, you should start it in uppercase. If you look at what I did here, it is uppercase, open new worksheet. And the name of the procedure is always followed by parentheses. You can see it here, parentheses is here. And lastly, if the name of a procedure is a combination of words, you should start each word in uppercase. Like you can see there, open new worksheet, the O is uppercase, N is uppercase, worksheet, the W there is uppercase. So this is just a practical view of procedure. It starts with the keyword sub and end with the keyword end sub. The section between the sub and the end sub lines is referred to as the body of the procedure. So this is the beginning and this is the end, while the section between the sub and the end sub lines is referred to as the body of the procedure. Number 3, we have variables. Variables are used to store and manipulate data within a program. They can hold different types of data such as numbers, text, or dates. Before using a variable, we need to declare its type. For example, in high school, we learned about algebra. Find x plus 2y where x is equals to 1 and y is equals to 3. In this expression, x and y are variables. They can be assigned any numbers. They can also be changed to say 4 and 2 respectively. Variables, in short, are memory locations. As you work with Excel VBA, you will be required to declare variables, just like in algebra classes. Now, this is an example of variables. I have declared the variables as integer, and here I am assigning values to the variables. So I said num1 as integer and num2 as integer, and num1 here is equals to 5 and num2 is equals to 10. And I said calculate the sum, which is num1 plus num2, and I want the answer to be displayed in a message box. So message box will give me the sum of num1 and num2, and if I execute it or I run it, it will be displayed in a message box. You can see it, the sum of 5 and 10 is 15. I can go back and change that figure of 5 and 10 to another number, and I will also get the answer that I want. Let's say, let's make it instead of 5, let's say 7, then instead of 10 we can say 15. Then we can run it and see what the result will look like. You can see the sum of 7 and 15 is 22. So this is an example of variables. When you get to the lesson that cover how to write VBA codes, you will get to know more about variables. And lastly, we have control structures. Control structures such as loops and conditional statements allow us to control the flow of our program. They determine how the program executes different sections of code based on specific conditions. It is the combination of keywords in codes used to make a decision that alters the flow of code the computer executes. Now, using control structures, you can write Visual Basic code that makes decisions or that repeats actions. Let's go back to our Visual Basic editor and let me show you an example. This is an example of control structures to tell us numbers that are even or odd. So I will execute it so you can see how it works. Alright, it said enter a number. So let me enter a number, let's just say 7. And if we hit the OK button, it will tell us if 7 is an even or odd number. Okay, 7 is an odd number. You can see that. So this is an example of control structures. We can also execute the button to try another number. So let's say 10. Let's see if 10 is an even or odd number. Alright, 10 is an even number. So that is just it. You can see that you can use VBA to write a lot of applications that do a particular task. So we have used this one to write an application that tells us which number is even or odd. Now, what are the difference between a macro and VBA? Well, VBA is just the programming language that macros are written with. That is just the answer. VBA is just the programming language that macros are written with. So there you have it for this lesson. Macros and VBA can significantly enhance our productivity by automating repetitive tasks and providing the flexibility to customize software applications according to our needs. In the next lesson, we are going to look into how to record a macro, how to run a recorded macro, and assign it to a button or shortcut. See you in the next lesson. Hello guys, we are going to dive into the world of macros once again, but this time we will focus on recording and running them. Macros are incredible time savers, and recording them can make our life so much easier. In this lesson, we will explore how to record macros using the built-in recorder. And the first thing you have to do is to open your Excel. So this is our Excel, and this is the data set I'll be working with in this lesson. To get where you can find your macro, you just go to the View tab, which is this. Click on the View tab. Then you can see macro at the right hand side. What you will do is to click on the drop down, which is this one here. Then you go to Record Macro. Then this will show up, and you give your macro a name. So let's enter a name. Let's just call it testing. Okay, and you have the opportunity to give it a shortcut key. So let's say H. Let's give it H. So the shortcut key is Ctrl+Shift+H. So that will do the work for us. Then store macro in where, always use this workbook for that. So you have a lot of options, but always choose this workbook. And you can choose to include a description if you want to, but you can skip that. When you are done with everything, you just click OK. So our macro is already recording. If you want to see that, you can take your mouse here and choose, you can see stop recording. So it is already recording. So let's now perform the activity we want macro to record and help us automate. So I want to change all these to proper case, and I want to use the Excel function to do that. So I just use the equal to, then the proper, open the bracket, then we choose this, close the bracket, then hit the enter button. That gives us the uppercase. Then we use flash fill to fill up the other cells. Okay, so this is what we want to do, and we have done it. Then we can click stop recording as I am done performing the actions I want to automate. So I take my mouse here and click stop recording. Okay, so we have created our first macro, but wait, where is the recorded macro? Because we can't find it here. We can't really see where our recorded macro is. It's very easy to view all the available Excel macros. Just select view. You can still go back to your view, then go to macros. You can see view macros here. You click on it, then you will see all the macro that has been created in your Excel. So we only have one macro here, which is the one we gave testing. So you just see it here, it's testing. You can also click this edit here to view the VBA code window. So let's see it for ourselves. Now this is our VBA code window. You can see testing because that's the name of our macro. Then testing macro, this is the keyboard shortcut. Remember, I gave it a shortcut key, which is Ctrl Shift H, and this is it. So this is the VBA code for that macro. As you can see, you don't have to write VBA code for macro. Excel automatically generated each code line based on the recorded keystrokes and mouse clicks. So this is the code line for the action that I performed. So you don't need to write VBA code. Excel automatically generate the code line based on the recorded keystrokes and the mouse clicks. Okay, so let's close it and go back to our Excel sheet. All right, now we have done that. Let's try to copy this same data set to another sheet. So let's paste it here and perform that same activity to see if we get the same result. So let's assume that you were given this data set and you were told to clean it up, and you want to clean it by correcting the case to proper case. So remember, the shortcut is Ctrl Shift H. Now that's what I will just do and see what will happen. So let me hold my Ctrl Shift H button and see what is going to happen. Ctrl Shift H. We already have everything. You can see within seconds we have already done that same job that I did in the previous worksheet. All I did was just to hold Ctrl Shift H, which is a shortcut key, and that action we performed in the previous worksheet was done within seconds. As you can see, it worked. So we don't need to start performing that activity again. This has helped us to automate this process. You can see what we did here using the Excel function manually before we could get this proper case here. We don't need to do that activity here again. All we just need to do is to use our Ctrl Shift H button, which is the shortcut, and everything was done at once. I'm very sure you have been able to see how macros help us to save time and become more productive. As far as you know what you want to do and you don't want to repeat that process all over again, you just need to record it with macro and store it there, so that next time when you want to perform that same action, you just use your macro and macro will do everything for you. So you won't need to start it from the beginning again from scratch. Running macros from the macros menu or using the shortcut key is convenient, but we can make it even more accessible if we are not the only person having access to the workbook. I want to show you how you can create a button for your macro. Why do you need to do this? This is because most times you may not be the only one having access to the data set. If you and a team is working with this same data set, how would they know a macro has been created to help them quickly get some tasks done by running a macro? As you can see on the screen right now, there is no sign that a macro has been created for this workbook, and someone with no knowledge about macro will not easily know where to get it done. So that is why it is very important to create a button for your macro if you are sharing the dataset with other members of your team. And outside that, it is also good for your own convenience. So here is how to get it done. Remember in our previous video, we used the macro to get the proper case. Now I want to create a button where we just have to click the button and that same job will be carried out. So to do that, what you need to do is to go to the Insert tab, which is here. You go to the Insert, then depending on the Excel version that you are using, you can easily see all these things. I am using Excel 365. So if you are using any Excel version, just find a way to really follow me, because I know that different version with different interface, but it's very easy. If you are using Excel 365, just go to Insert, then go to Illustration. You click on the drop button, then you go to Shapes, and also click on the drop button. If you are using a different version of Excel, you may not see illustrations, you may just see Insert, then you go to Shapes. So depending on what you are using, but the main thing is we are going to Shapes. So look for how you can go to Insert tab, then look for Shapes. Now we're just going to pick a simple shape. Let's just pick this one. You can pick any shape you want to use for your button, but let me just pick the rounded rectangle. So when you click that, you just draw any button here. So let's just draw a small button. Okay, let's look like this. Then we can just write on it. Let's just say you can give it any name that you want to give to it. Let's just say proper case letter. So let's just say proper case letter. And when you are done, you can also work on it. So let me change the font. Go to home. Let's make it 14. Okay, let's make it bold. Let's put it at the middle. Okay, it's too much. Let's make it 12. All right. So we can also expand it if you want to, so that the letters can go in. So let's just make it 14 if that is possible. All right. So this is good. Then we have created our button. The next thing you have to do is to click on it. Then you right click and go to Assign Macro. So you click on Assign Macro. Then you choose the macro. Remember, we have our first macro, which is testing. So I'm going to choose this one. Bring it up. So I'll choose this one, which is the macro that I want to activate on this button. Then you click on the OK button. So right now we have assigned our macro to this button right now. So watch what is going to happen. We are going to click this button and the proper case will be done as if we are using the shortcut key or we are just running the macro. So let me put my mouse here. Click on this active cell. Now I'm going to click on this button and watch what is going to happen. You can see exactly what I needed. All the letters have been changed to proper case. So that is how you can create a button and assign macro to it. This is very relevant if you are sharing your data set with another person. So if someone comes to this part right now and the person wants to change these letters into proper case and the person sees this button, he or she will know that, okay, this is the purpose, and click on it and it's done. But if there is no button here and the person is not aware that a macro has been created and this person has no idea about macro, he or she will start using the Excel function to get it done. But if this button has already been created and it is in this workbook, the person working with this data set who want to work on something like this, we just have to click on this button and the job will get done. The action will be performed. So that is why it is also important to create a button for your macro. And instead of using it with your team, for your own personal use, you can create and assign any macro to any button. So that is how it is done. Now, in case you want to try it yourself, not just to watch video, I am leaving the dataset in the resource box. So the dataset is available for you in the resource box for you to download and just use it to rate your understanding about this topic. So I'm leaving the dataset in the resource box. You can go download it and try to create the button yourself and also try to create your first macro. All right, see you in the next lesson. In this lesson, we are going to take a deep dive into the world of VBA coding. VBA, which stands for Visual Basic for Applications, is a powerful programming language that allows us to unleash our Excel superpowers. In this lesson, we will familiarize ourselves with VBA syntax, variables, data types, and perform a task using VBA coding. So fasten your seatbelt and let's embark on this exciting coding adventure. Now, what is VBA syntax? VBA syntax refers to the rules and structure that govern how we write VBA code. It is like the grammar of the VBA language. Understanding VBA syntax is essential for writing correct and effective code. Now we have key elements of VBA syntax. We have the statement, the comment, and the indentation. For the statement, in VBA, code is written as a series of statements. Each statement performs a specific action or task, and statements are typically written on separate lines and end with a line break or a colon. While for comments, comments are essential for documenting your code and making it more readable. In VBA, comments start with an apostrophe, and anything after the apostrophe is ignored by the interpreter. While lastly, we have indentation. Although not mandatory, indenting your code improves readability and makes it easier to understand the structure of your program. Top programmers usually use consistent indentation to enhance code clarity. You will get to know all these key elements when we begin to write our code, so just stay with me. Now we have what we call variables and data types in Excel VBA. Variables are like containers that hold data in VBA. I talked about it in our previous lesson. Before using a variable, we need to declare it using the dim keyword. For example, dim my variable as integer. The keyword dim is short for the word dimension. It is used to declare variables and their types. And when you use it, it tells VBA that you are declaring a specific name as a variable and assigning a specific data type to it. We are going to apply it when we get to the part of writing our VBA code, so just stay with me. Number 2 is the data types. VBA supports various data types such as integer, string, boolean, double, and date. Choosing the appropriate data type is crucial for efficient memory usage and avoiding type-related errors. And lastly, we have the variable assignment. Variable assignment, we can assign values to variables using the assignment operator, which is equal to. Here we can say, for example, my variable is equal to 10, or x is equal to 10, and y is equals to 5. So that is the meaning of variable assignment. So we can assign values to variables using the assignment operator, which is equal to. Equal to this is the assignment operator. Alright, now that we have a good grasp of VBA syntax, variables, and data types, let's put our knowledge into action and learn how to write simple VBA code to manipulate Excel objects. Now, before we can begin to write our VBA code, we need to get access to the VBA editor. To get access to the VBA editor, you need to enable the developer tab. The developer tab gives you quick access to some of the more advanced features and functions available in Excel. By default, the developer tab is hidden, but on hiding it is very quick and easy. So I have already enabled mine, but if yours is unable, so this is how you can do it. Just take your mouse to this ribbon here and right click. Then you go to customize the ribbon. Then this will show up. All you need to do is to go to this place where you see developer and tick the box. When you finish ticking the box, you just click OK and the developer tab will appear here. You can see mine is here. By default, the developer type is always hidden. So if you have not enabled yours, this is how you can just do it. You take your mouse, right click, go to customize the ribbon, then you tick the developer box and automatically it will appear here. Okay, so now I want to write a VBA procedure that will help me split an Excel worksheet into individual workbooks. If you look at the screen right now, you will see that I have a lot of worksheets here. So I want to split each of them out of this workbook and make them stand alone as different files. So I have like 1, 2, 3, 4, 5, 6, 7, 8. I have 8 worksheets right now. I have 8 Excel spreadsheets. Now I want this spreadsheet to stand alone as a workbook, which means I want to split each of these worksheets into individual workbook or into individual files. And I want to use VBA to do that, because if I'm to do it individually, it will be very boring. I will have to open a new Excel file, then copy this into that Excel file, close it, do it 8 times, which should be very boring and kind of like time consuming. So I want to write a VBA code that will do that job for me within 5 seconds. Yes. Now, the first thing you have to do is to first create a folder and drop the Excel file into the folder. I have done that. This is the folder that I created. So this is the main folder that I created. I created it for this purpose. So this is the folder and this is the main sheet here. The one that is open here, this is it here. That is the first thing that you have to do. You create a folder and drop that main Excel worksheet into the folder. Now, when you have done that, go to the developer tab, which is this one here. You click on it. Then you go to VBA editor, which is Visual Basic. You can see it here. Open the Visual Basic editor, or you can use the shortcut, which is alternate F11. So you click on it and the Visual Basic editor will open. The next thing you have to do is to either take your mouse here, click insert and click module, or you can just right click here and go to insert and click module. It is the same thing, just two ways to get it. So you just click module, and here we have our tab open for us to start writing our code. So I'm going to copy and paste my code, then I will explain everything step by step. So here's the VBA code that will do that job for me. Now let me explain each of this line one after the other. Now I know you already have an idea of this part because I explained it in the previous lesson. So this is sub, which you already know that. And the name given to this exercise is called split each worksheet. Remember, I gave the rules of how it should be written in the previous lesson. So split each worksheet is what I want to do. And as usual, you always end it with a parenthesis. Then dim WS as worksheet and also dim 5 part as string. In our previous slide, I talked about dim, which stands for dimension. So dim means I'm declaring WS as worksheet. So that itself is a variable. I'm declaring WS as worksheet, which means anywhere there is WS, it stands for worksheet. So you will always declare a variable. So I'm declaring WS to stand as worksheet, and I'm declaring the 5 part as string. Now, what is the 5 part? The 5 part is where I want to copy all the Excel spreadsheets to. So that is the 5 part. So I want to split those Excel worksheets into individual files, and that is the part I want to put it there. So I am declaring it as string. What is a string? A string is a sequence of characters. The strings variable is used to hold strings of text. Now, I wrote something here, folder for the new files. This statement here is called comment. Remember, I said it when I was showing you that slide. When I said comment, I shared with you what comment is. Comment makes your work kind of like readable. It helps to describe the written code. And one good thing about it is that VBA ignores it while executing the code. They are used for the benefit of the programmer or future programmer who needs to understand the code for maintenance. So that is why it is very important to write comment, so that in case you are reading my code, you can easily understand every single statement, every single line. Okay, so folder for the new files. This is the folder for the new file. I said 5 part equals to. So I'm going to include the link here, which is the link for where I want to copy and paste that my files. So I'll go back to the folder and get the link. So to get the link for this folder, just go to this place and click, and the link will show up. Then you just copy, which is Ctrl C, and go back to your VBA editor and paste it there. So let's paste it. So this is the 5 part. This is the part that I want all the Excel worksheets to be copied to. So you must always declare a 5 part. All right. The next comment, I said, look through each worksheet in the workbook. And I wrote, for each worksheet, remember WS, I said, declare WS as worksheet. So for each worksheet in this workbook.sheet, this workbook there refers to the present sheet that the code is written in, which is the main sheet, which is this one here. So this is our main sheet. This is the sheet that the VBA code is affecting. So I said, for each worksheet in this workbook.sheet, this line set up a loop that repeats itself through each worksheet in the current workbook. This is the workbook that the VBA code is affecting. In case you are confused, the Excel file itself is the workbook, while each of this sheet here is called worksheet. So don't get yourself confused. Each of those pages, or yes, each of these pages is called the worksheet. Let me use the word, but the file itself is called workbook. So the VBA code is written to affect this particular workbook. Okay, so this line here set up a loop that repeats itself through each worksheet in the current workbook. This statement for each is a loop statement that allows you to repeat a code for a set number of times in a sequence. So the VBA code will run for each of the worksheets inside the workbook. So for each is a loop statement that allows you to repeat a code for a set number of times in a sequence. While this worksheet.sheet here refers to the collection of worksheets within the current workbook. So this is how it is written. This workbook represents the workbook containing the VBA code, and sheet there is a property of the workbook that holds a collection of all the worksheets in the workbook. So that is what it means there. So dot sheet means that sheet itself stands for each of the worksheets inside the workbook. Then I said ws.copy, which means we want to copy each worksheet. So copy the current worksheet to the new workbook. Remember, we are copying each of these worksheets to form a workbook. They will stand individually by themselves. Now we have a worksheet here that says we have a worksheet. This one is index, this one is count if, this one is sum ifs. So these names here will stand as a workbook on their own. So we won't need to come here to look for them again. They will not stand as a single file. I know you may not get it now until when we get to the end of this, you will understand better. So let's just continue. Okay, so copy the current worksheet to the new workbook, which is ws.copy. That is how it is written. And before we proceed, have it in your mind that for this line of code is particularly used when you need to apply a set of actions or perform similar operations on multiple worksheets within a workbook. So you need to cram some of these lines yourself so that you can use them for other things also. So have it at the back of your mind. Why this is just to copy worksheet, the current worksheet, to a new workbook. So it is ws.copy. Then the next line is application.activeworkbook.saveas, which is the file equal to file path, the worksheet name, and the extension. You know, Excel extension is this. Let me break down the meaning of each component. Now let's start with this one here, application. Application, this refers to the Excel application itself. It is a built-in object in VBA that represents the Excel application and provides access to its various properties and method. While for this .active workbook, this refers to the currently active workbook, which is what I showed you before. It represents the workbook in which the VBA code is currently running. So that is .active workbook. While the .saveas, which is this one, this is a method of the workbook object that is used to save the workbook with a new file name or in a different file format. So save as, then this is the file name. This file name here is a parameter of the save as method that specifies the file name and the path for the save file. So we don't need to start putting that file path here again, because while we have already cleared that file path is equals to this link here. So anywhere we put file path, it is already representing this link here. So we just have to write the name here. So we don't need to start putting that link there again because I've already declared it. So the file path is a variable that represents the file path where you want to save the file. Okay, then we have the AND, this AND here. This is a concatenation operator in VBA. It is used to combine strings or variables together. In this case, it is used to concatenate the file path, which is this one here, with an empty string, which is this one here, to ensure the correct formatting for the file path. And also we have two AND here, so it is combining two strings. And we have the ws.name. it represents the name of the current worksheet within the loop repetition. Why did we do this? This is to make sure that each of these Excel file will carry the name of their worksheet. So we have a file that is called if, another file will be called VLOOKUP, just like that. So then we carry that name along with themselves. Then we have this one here. This is the file extension for Excel files. It indicates that the saved file will be in the Excel workbook format. So if you want to save yours in CSV, you can decide to change that extension there. So when this line of code is executed, it saves the active workbook with the specified file name and file format at the location specified by the F part here, which is this one here. So all the file will be saved in these 5 parts. Alright, so we have closed the new workbook. Now this line of code closes the newly created workbook without saving any changes. The first argument, which is this one here, this first argument here, indicate that the workbook should not be saved before closing, which means if you have made any changes before you perform this action, that changes you made will not be saved. So that is the work of the first argument. I use it because I did not make any change to each of the workbooks. So if I have made any change and I want that changes to be saved, I won't use this argument there. But I just included it there because I know I didn't make any change and I want each worksheet to remain the same. That is why I included this argument here. The next one is next WX, which is next worksheet. This keyword moves the loop to the next worksheet and the process repeats until all worksheets have been processed, which means after the action has been performed in one worksheet, it moves it to the next worksheet and perform that same action to the next one, the same action to the next one, till all the worksheet has been processed. And I want a message box to tell me that the worksheet splitting is completed successfully. So I just want to display a message when the splitting is completed. So this is how you can do that. It's message box, then you open apostrophe. Then you can write any statement that you want to write. I just want to write worksheet splitting is completed successfully. Then I include a comma. I want that title there to have notification. Just the way you have message alerts on your phone or anywhere else. I want mine to appear as notification. Then we have the end sub. You already know what this means. Remember I explained it in the previous lesson. So the end sub end your VBA code. Alright, so I'm very sure you understand all the parts of this FBA procedure. If you don't understand, you can repeat this part of the video so that you can get the real message. Alright, so it is time to execute the VBA code and let's see the action that's going to take place. Okay, so I'm going to run this code and we are going to see how it will be done and the seconds it will take to do that. It won't be up to, let's say, 10 seconds. I will go to our folder and you will see how each of the file will be created individually. So let me run the code and you will see how it will be done. So I'm going to execute it right now. Let's go. The if is been created. The sum if has been created. That is the sum if x. This is the count if index. This is the index match. VLOOKUP. We have the X lookup. And we are done with everything. As you can see, it wasn't even up to 10 seconds. Let's check if we have that display message. Let me minimize this. Oh, as you can see, worksheet splitting is completed successfully. You can see that worksheet splitting is completed successfully. And look at the notification that I said it should write on top. So if I click this, it's already done. This is our worksheet. So let's assume you have a report and your boss wants you to split each of those worksheets into individual files. You can use this VBA code to get that job done. You can see one benefit of knowing how to write VBA code. So there you have it for this lesson. I am very sure you understood this very well. For your own, I am leaving the dataset and the VBA code files in the resource box. I will advise that you watch this video twice for better understanding. So I'll be leaving this VBA procedure as a file in the resource box, and I'll be leaving the dataset also so that you can practice it and understand it better. Remember, you'll be using a different 5 parts here, so you have to copy your own 5 parts and paste it here. So you won't need to use mine because we're not using the same computer. All right, thank you for your time and see you in the next lesson. Range and cells are fundamental objects in Excel VBA that allow us to interact with data in the worksheet. In Excel, a range refers to a group of cells, and it can be a single cell, a row, a column, or a more complex rectangular selection. VBA uses a specific syntax to refer to ranges and cells. In this lesson, we learn how to effectively reference and manipulate ranges and cells in VBA. It is important to be aware of the different ways you can write to access cells with VBA or macros. I'm going to show you how you can reference range and also reference cells. If you know all this, you can easily manipulate your VBA code or macros. So let's start with our code. Let's say sub range ref. Okay, so let's write this range, open a bracket, double quote, A1, double quote, and we close the bracket. We say dot value equal to 54. Now this value here, dot value, is a property of the range. It is a default property, so even if I leave it out, it will pick the value as a property. So I can decide not to include dot value. I can just write equal to 54, and our VBA code will still pick the value as a property. Now we are referencing a range which is A1. What is our A1? This is A1 here. Is A1, row 1, column 1. So if I run this code, I want to impute this number here, 54, into A1. So I will run this code and you will see what's going to happen. As you can see, we have 54 here. So that is me referencing A1, which is column 1, row 1. I can also do it like this. Let's say cells, open a bracket, can say 1, 1, close the bracket, dot value equals to 32. So what does this mean? Let's check it out. Row 1, column 1. So let's run it. You can see this is 32. So I can either use range A1 or I can use cells 1, 1, which is the same thing as row 1, column 1. So what if I do something like this? Let's say I write range, then A2, C2, close the bracket, equal to, let's say 50. Alright, so this is A2, C2. Where am I going to get this record? Let's check it out. You can see where we have it, A2 through C2, and we said 50. You can see it happens. It appears in A2, B2, and C2. So this means I want to impute 50 from A2 to C2. Now, what about this? Let me take this out so that it does not repeat itself again. Okay. So let me make this a comment so that VBA can ignore it. Okay, so what about I write something like this? Range A2, then C2, I include a comma, E2, F2. So let's say equal to 32. So I'm including a comma, then E2, F2. Let's see what's going to show. Oh, you can see it right now. This is from A2, B2, C2. It omitted D2 and it went to E2 and F2. You can see A2 through C2, then I included a comma, then E2 to F2. Now let's see this one also. Let me make this a comment. Okay, so let's see this one. Range A4, comma C4. So let's see what is going to happen. Equals to 44. Let's see how it's going to appear. Sorry. Range. Okay, let's bring it down. Now let's see what is going to appear here. You can see it right now. I said A4, comma C4, and this is what we got. A4, which is A, then row 4, then C, and also row 4. So this is how you can use the range to impute data into different cells in your Excel sheet. Now, to make referencing range or cells easier, you can do something like this. Let me take this out. Let me first declare a variable dim test as range. Then I can say set test equal to range, and our range is A1 and D4, so A1 through D4. The set there is used when assigning a reference to an object variable. So in this case, we are assigning a reference to a range of cells. Then I can say test equal to 32. Okay, so I want to run this so we can see for ourselves. So the word test refers to a range of cells, and it is used when you want to reference a range of cells. So instead of me repeating this particular keyword range every time I want to write my code, I just have to use the word test. So if I want to reference that particular A1 through D4, I just write the word test, and anywhere the keyword test appears, I am referring to range A1 through D4. So I want to input the data 32 into those cells. Okay, so let me run the code and see what's gonna happen. You can see here we have 32 all through from A1 to D4. You can see it, A1 through D4. If I want to clear all the data right now, let's say in range B2, I can just write this. So let me take this out. I can just say range B2 dot clear. Okay, so if I run my code, it's going to clear any data in B2. And you know our B2, this is our B here, and this is our B2. So if I clean this, it's going to clean up. You can see it is out of here. So if you want to clean everything in column B, I can just say B2 through B4. So let's see what's going to happen. You can see from B2 to B4 is out. Sorry, I did not include B1. That's why you can see from B2, B3, B4, they are all out. I didn't include B1. That is why we still have this 32 here. Now, there's another way you can also do this. Yes, there's another way you can do this. So we can just say range. You can say range. Use another column. Let's say C2 through C4. Okay, let's say C1. So everything goes out. Then dot value equal to, so I'm giving an empty value in the cell which is range C1 to C4. So this is another way we can also clear data. If I run it, everything is C1 to C4 will be out. You can see it there. So we have everything out of that range. Now if I want to clear the content in all the cells, it is still easy. So I just do this cells dot clear. That just it. That just the keyword cells dot clear. You run your code and boom, everything is out of the worksheet. So these are little things that you should know so that you can be able to write your code effectively. Now let me show you how you can count property of range. First I have to define a range, but first let me define a parameter. So dim, let's use another word, sample as range. Then let's set sample equal to range, and our range is what, let's say A1 through C4. Okay, then I want to insert a value into this range. So I will say sample dot value equal to, let's say 22. Then I will run the code and you will see what's going to happen. Okay, so I've inserted the value 22 into this range, and if I want to calculate the number of cells that has data in them, it is very easy. If I want to calculate the number of cells and also show it in a message box, I just need to write this message box, then sample dot count. So the count function can be used to count the number of cells that contain data within a specified range. so dot count. Then if I run this, you're going to see what's going to happen. It will count the number of cells that we have value inside and tell me by displaying it in a message box. You can see, so we have 12 cells that numbers are in, and if you do that, you see that it's true. This is 3 and this is 4, so 3 times 4 will give you 12, and here we have it. So that is how you can really reference, range, and cells in VBA. It is very easy. Knowing all these things make your code easy for you to write. So I'm very sure you know how to reference, ranges, and cell with the help of this video. Now, please, if you have not dropped a review for this video, I will beg you to go do that right now. Drop a review and your rating. Tell me what you feel about this course. Do you like it? Was it a good investment with your money? But if you are still in doubt, no problem. You can keep going. And when you are done with the course, then you can drop your review and your rating, because it counts towards making other people know about this course. The more reviews and rating I get, the more Udemy increase the reach of this course to other people. Alright, so see you in the next lesson. As an aspiring Excel VBA expert, understanding control structures and loops is crucial in developing robust and efficient macros. These powerful tools will elevate your programming skills, allowing you to automate repetitive tasks and make your code more efficient. Now, what is control structures? Control structures allow you to control the flow of your macros based on specific conditions, making your code more dynamic and intelligent. Control structures serves as the building blocks of any programming language, allowing you to control the flow of execution based on certain conditions. In Excel VBA, we have two primary control structures. They are the if-else statement and select case statement. These structures enable your program to make decisions based on certain conditions, opening the door to dynamic and flexible code. First, let's explore the if-else statement. If-else statements are fundamental control structures that allow you to make decisions in your macro. They execute different blocks of code based on a condition. It allows your program to execute different blocks of code based on whether a condition is true or false. Let's go to our Excel spreadsheet and see an example for ourselves. In this example, I want to grade this exam sheet. If the student score more than 35, then the student pass. But if the student score below 35, that means that particular student fails. And I want to use VBA code to state those that passed and failed the test based on their marks. Okay, so I will go to the developer tab, then click Visual Basic Editor, then I'll go to the insert and click module. Okay, so this is our tab. I've already copied my code, so I will just paste it. Alright, so this is the code that will do the job for me. But before I execute, I want to explain the code. Now, this is our sub if sample. This is the title, or this is the name of the code. And dim s as integer. I'm declaring a variable here, and the reason is this: I want to use the loop function here. That is why I am declaring the variable. If I were just to do for a particular cell, I won't need to declare any variable. I will just go straight to the particular cell. I want a situation whereby it gives me the answer for all of the cell, which is this one here. So I want the answer to run all through this cell. That is why I'm declaring a variable. So I'm declaring x as integer. Now the word integer means number. So if you see me declare any variable as string, it means I'm declaring as a text. But if I declare any variable as integer, it means I'm declaring that particular variable as a number. So get that right now. When you declare x as integer, it means x in your code will be number. And I said for x equals to 5 to 11. Why is it 5 to 11? Let me show you my Excel sheet. If you look at this Excel sheet, our table started from here. And if you look at the rows, it is row number 5. So that is why I'm using 5 to 11. So this is 5 to 11. Remember, 4 is the heading, so I can't really choose 4. But it started at row number 5 to row number 11. That is why I declare x as 5 to 11, which means I want my loop to run from row 5 to row 11, which means the answer will start from here and end here. That is the row 11, 5 to 11. Now this is the line where we apply the if else statement. I said if says open a bracket x comma 3 dot value greater than or equal to 35. Now what is this x comma 3? It's very simple. Now says there means the particular cell that we want this code to affect. So x comma 3, what is this x? Remember x is our integer here. Then comma 3, let me show you in the worksheet. If you look at this worksheet right now, this is the first column, this is the second column, and this is the third column. And remember, this code loops through this column, and if the criteria is met or whatever, even if the criteria is not met, it now updates in this column, which is the fourth column. So this is the x comma 3. That 3 there represents column 3. So please try and understand that part. Always count the column you are working with. So this is 1, 2, 3, which is the x comma 3. And we also have x comma 4, which is this one here. So if I'm to refer to this column, it will be x comma 4, which you will see in the code. So I said if says in bracket s comma 3, which is the third column, x stands for the integer, which is from 5 to 11, dot value greater than or equal to 35. Remember I said if the student score any number above 35, that student pass. But anything below 35, it means the student failed. This is how you write it. If says, then you state the column, then it is dot value. Value means the number. So when you use the keyword value, you have to represent it by a number. You can say value equal to this, value equal to whatever you want to use. Now, when you are using a number, you don't use the double quotes. You can see here we use number here, which is integer. We didn't use the double quote. But when we use text here, we use the double quote. So if you're writing a string, you use a double quote. But if you're writing an integer, which is number, you don't include a double quote. Okay? So I said if says x comma 3 dot value equal to or greater than 35, then column number 4 should return pass. If you look at here, I said then says x comma 4, which is this is 4, 1, 2, 3, 4. So if x comma 3 is greater or equal to 35, then x comma 4 should produce pass. Okay, then says equals to x comma 4, the value it should produce is pass. Hence says x comma 4, which is that same column, value should give us fail. So it's very easy. So if the condition is false, the code sets the value of the same cell to fail. Then we end with end if, which means we are ending the if else statement. Then we go to the next x, which is the next number. So the loop continues for each cell until it reaches 11. Remember I said for x we declare it as 5 to 11. So next x means go to the next cell from 5 to 6 to 7 to 11. That is the next x. If you don't include this and you just end your sub, you are going to get error. So you use next x till it gets to 11 before it now end the sub procedure. In summary, the code loops through 5 to 11. Check the value in column C, which is this one here. If the value is greater than or equal to 35, it updates the corresponding cell in column D to pass. Otherwise, it updates it to fail. So let's run this code and see what we are going to get. So let's run it and see the result we get. Okay, our code has been executed. Let's go check it. Alright, you can see it right now. It has been done. So this is pass, pass, fail because it is less than 35. And we have fail here again because this one is less than 35. So we have been able to grade this result using VBA code and using the if else statement. I told you before that the if else statement execute different blocks of code based on whether a condition is true or false, and we have just performed an example to show how you can use the if else statement to score a grade or anything that has to do with condition. If this is this, then this, then if it is not this, else it should give you this, which is what we did in the code that we wrote. So this is the code that we wrote, and I'm very sure you really understood it because I explained it in a layman way. I'm going to leave this VBA code in the resource box so you can go use it for your own practice. I will also drop the data set for you also so you can use it for your own practice. Let's go to the next one, which is the select case statement. Moving on to select case statement. Select case statement provide an elegant way to handle multiple conditions and simplify complex decision making. They compare a variable against various values and execute specific code blocks accordingly. Let me show you how you can use a select case statement to find a particular data when you are working with a large data set. So we are assuming that we have a large data set and we are asked to look for a specific data in that same data set. You can use the select case statement to achieve that. Let me show you how. Now I want you to assume that this is a large data set. I'm just using this as an example. So I want you to assume that this is a large data set with employee ID number from 110 to like 1110 and has names, has department, has other things. Now we want to use the VBA code and in particular the select case statement to look for specific data in the data set. So you can use the select case statement to get that. Although yes, we can use VLOOKUP, we can use Excel function to do that, but we are basically treating VBA code, and that is your area of interest. And I will show you how you can also achieve that using the select case statement. Now I've already written the VBA code. I just want to open the Visual Basic Editor and show you the code and also explain to you how it runs in case you want to try it yourself. So this is the code. Let me explain. Sub select case statement. This is the name of the code. Then dim x as integer, and so I'm declaring a variable here, and I want x to be an input box that has a statement enter employee ID. So we are kind of like creating a search box. Let's use that, but like a search button. So the X will stand for an input box where we have to input the employee ID to get the particular employee. Now, when I said select case X, so X is like the finder, the search lens. Then if the person enter ID 110, a message box will appear telling us who that particular person with employee ID 110 is and the department. So I wrote the department in bracket, which is HRO media marketing, just like we have in our Excel worksheet. And remember, I am assuming that we are working with a large data set. So though it will take time to create this, yes, for sure. But when it is done, it is done. You won't need to go back and do it again. So you can take your time to write this. Depending on what you want to write, this is what I wrote myself. You can decide to choose whatsoever you want to write. I want mine to appear as a message box, and this is what I want to appear. This is the same thing that we have in the Excel spreadsheet. So this is case 110, which is the employee ID, then message box this. Okay, so this is how you use the case statement, this select case statement. Then when you have done with that, you can go down and see case S message box. I particularly included this. Normally you can do without this. So I want a situation whereby if someone imputes an employee ID that does not exist in our database or in our data set, it will return an invalid ID. So the message box will tell you invalid ID, which means we don't have that particular employee ID in our data set. So that's just me customizing mine, but you can do without it. So select case X, which is this. Case S, which means if it is not there, return invalid ID. Then you end the select, which is end the function. Then you end the sub. And also to beautify it, we can also kind of like create a button. Yes, whereby we click the button and the input box opens and we input the ID and everything comes up. Let's just make it beautiful. So you can save your VBA code by just using Ctrl S. Yes, you just use Ctrl S, it saves. Then you can go back to your Excel spreadsheet and let's create a button. So let's make it beautiful. Let's go to our spreadsheet. I've done this in the previous in one of the previous lessons. So go to insert, you go to illustration, we choose a shape. So let's pick a shape. Let's pick this one here. Let's draw a small button. Okay, this is okay. Let's type click to search. Let's bring it to the middle. Let's increase it. Let's say 16. All right. Now we have a button. Then we right click and assign a macro to it. Remember, we have already saved our macro. This is it here. So you click OK, and there we have it. We have assigned our macro to this button. So all we need to do is just to click the button and we have to input the ID. So let's do it. Click the button. Okay, enter employee ID. Let's just say 115. Then hit the enter button or you click the OK. You can see Andrew Flow, and if you confirm this is Andrew Flow, this is marketing, so it is working. We can also try another employee ID. Let's try another one. So let's say 119. Who would that be? This is Team Joe's Media, and you can see Team Joe's Media. Now let's try an employee ID that is not in our data set. So let's click the button. Let's type 130. Let's see what we show. Pop. All right, you can see invalid ID, which was what I wanted. So that is how you can use a select case statement in real life data or in real life scenario. It is very easy. You can see the code for yourself. There is the code, so you can give it a try, work on it, edit it, put your own details, and make sure you don't get error when you are trying it by yourself. Another loop at our disposal is the do loop. Do loops are versatile structures that repeat a block of code until a certain condition is met. The do loops provide more flexibility in controlling the looping process. The do loop is particularly used when we don't know in advance how many times the loop needs to execute, as we can dynamically control the loop's termination based on a specific condition. There are two types of do loops. We have do while loops and the do until loops. What is the do while loops? A do while loop executes the code block as long as a specific condition remains true. This loop structure is handy when you need to repeat a task until a certain condition is no longer met. Let me show you an example using a spreadsheet so that you can understand it better. Okay, so this is our data set, and here we want to calculate the benefit of each employee using their salary, and the formula for doing this is 40% of each employee's salary. So that is how we can calculate the benefit each employee will get. We already know their salary and we are asked to look for the benefit of each employees, and the formula to get it is 40% of each employee's salary. We can use the do while loop to get the answer to this. It's very easy, so just follow me as I show you how you can do it. We open our developer tab, then we go to Visual Basic Editor to write our code. I already copy my code, so I just have to paste it here for you to see, then I will explain it. Okay, so this is my code. This is the title of the code. Then dim s as integer. The variable x is declared as an integer and assigned a value 3 because the data set started from row 3. So you can find it here. You can see row 1, row 2, and row 3. This is where the main data set started from, excluding row 2, which has the heading. Okay, so let's go back. Then do while, this is where we now use the do while loop. Says open bracket x comma 3, which is here, refers to cell in the x row and the third column, which is column C. So the loop will continue as long as the cell is not empty. So this 3 stands for the third column. If you look at the data set, the calculation begins here, and this is the third column. This is the first column, second column, and the third column. So that x comma 3, the 3 there stands for the third column, and the loop will continue as long as the cell is not empty. Then says x comma 4 dot value equals to cell x comma 3 dot value multiplied by 0.4. Inside the loop, the value of the cell in column C, which is the cells here x comma 3, is multiplied by 0.4. It is 40%, and that means 0.4. The result of the calculation is assigned to the cell in the same row but in column D, which is this cell x, 4. So this is x, 4. So the calculation starts here and the result of the calculation is assigned to the cell in the same row but in column D, which is s, 4, and this is the s, 4. So this is s, 3. This is where the calculation starts. The result appear in this column, which is the fourth column. Then the next line we have x equals to x plus 1. The variable x means that x is increasing by 1, moving to the next row for the next repetition of the loop. So that is just it. So x equals to x plus 1. The variable x is increasing by 1. Then we have the loop here. The loop continues until an empty cell is encountered in column C. So the loop means when the code runs to this place, it goes back again and continues until an empty cell is encountered in column C, at which point the loop terminates and we now get to the end sub. Once the loop finished, the subroutine also end. So this is the procedure to do that calculation that we want. We want to get the benefit of each employee, and the benefit is 40% of the salary. This is how you can write it. Like I said before, it's very easy. You just declare a variable and assign a value to that variable. What you assign here will depend on where your data set started from. Mine started from row 3, so that is why I have 3 there. If your data set starts from row 2, you can use that as your x. So mine started from row 3, that's why I'm using 3 there. Then you continue, which is the do while. Remember, this is the loop and we are using the do while loop. So the do while loop comes in, then says, then in bracket x, 3. That 3 there refers to the third column, which is column C. And the loop will continue as long as the cell is not empty. So this is how you do it. It's an empty cell. Then we now go to the next column, which is the cell x, 4, which is where we want the answer to appear. Then dot value. The value is equals to cell x, 3 multiplied by the value, which is 0.4. So we are multiplying 0.4 with the value in column 3. Okay, so I will just click on run and let's see what's going to happen. All right, so let's go back. You can see the answer has been generated. This is the answer for all the benefits for all employees. You can see we have been able to use the do while loop to get the answer. Now, I don't know if this question is in your mind, but if it is in your mind and you are asking, how do we know when to use the do while loop? This is when you should use the do while loop. Use the do while loop when you want to repeat a set of statements as long as the condition is true. So if you have a set of statements or if you have a condition whereby it is the same and you want it to repeat for all the cells in that particular column, then the do while loop is preferable to be used at that scenario. So as far as you know, this condition or this formula will not change or does not change, and you want that formula to run all through the data set, that is when you use the do while loop. Like for this one we just did right now, no empty cell and everything is just true, which is what we want, 40%. No opposite condition, nothing like there is a clause somewhere. It's just 40% or true. That is when you use the do while. Okay, so I'm very sure that is clear right now. Let's go to the next do loop function. The next one is do until loop. A do until loop is similar to a do while loop, except it continues executing the code block until a condition becomes true. So for do while loop, the condition is already true and you want it to repeat until the condition is no longer true again. But for the do until loop, it continues executing the code block until a condition becomes true. This type of loop is useful when you want to repeat a task until a certain condition is satisfied. I know this may not really be clear, so I want to give you a real life example so you can see it at work. Okay, this data set here, we want to use the do until loop to calculate the sum of these numbers and display the result in this cell here, which is B2. Normally we can use the sum function, which is the Excel function, to do it, but we can also use the Excel VBA, in particular the do until loop in Excel VBA, to achieve that result. And that is what I want to show you right now. So let's go to the Visual Basic editor. So here's my procedure, and I want to explain it as I normally do. Okay, so this is the title. Then I'm declaring a variable here, which is dim x as integer. Then I'm declaring another variable again, which is dim sum result as double. Now the sum result is the total result that I want at the end of the day. Why double? Why did I use double here? Why didn't I use integer? Or this is the first time you are seeing double? Yes, double is a data type used to represent double precision floating point numbers. Double precision means that it can store decimal numbers with higher precision and a large range of values compared to the integer data type. So that is why we use double. So in case you see someone writing the VBA code and use as double or as long, these two data types are much more bigger than integer. The double data type can store numbers with decimal places and bigger numbers that integer cannot store. I just say let me use it there so you can see that we can also use another data type. So if you don't know the answer, or you have a feeling that the number may be bigger, you just use double so that you won't get error at the result. Okay, so let's proceed. Then we have x equals to 2. This means that the loop will start from the second row in column A. If we check, you can see this is x equals to 2. So our loop will start from here. That is why we have x equals to 2. So it means that we start from row 2 in the first column, which is column A. Then we have the do until the cell x comma 1 equals to empty cell. So the loop will continue until an empty cell is encountered, which means the loop will run from 2 here to this place. Then when it gets to this point, this is an empty cell, it will stop. So that is the meaning of that statement there. Then the x comma 1 means 1 here stand for the first column, which is A, which is where we have the numbers there. So the column where you have the digits that you want to sum or that you want to work with is what you include here. So if that digit is in column 2, you clean that one there and put 2 there. If it's in column 7, that place we have 7 there. So it will continue until an empty cell is encountered. Then we have the sum result equals to sum result plus the result, which is the value we have in the first column there. I also explained this x equals to x plus 1 in the previous one. Then loop, you can see it goes back again. So when it calculates this, it goes back. Then this is the result, output the result in cell B. So this is 2 comma 2, then equals to the sum result. That is where we want the sum result to come out. 2 comma 2 means row 2 column 2. If you look at this column here where we want the result to come out, this is column 2, and if you look at it, this is row 2. So that is the 2 comma 2, which is row 2 column 2. So then we end the subroutine. So let's run this procedure and see what we are going to get. Okay, if we have done that, let's go back to our spreadsheet and see the results. Okay, so we got 45. So the sum of all these numbers is 45. If you want to confirm, you can run your Excel function, which is a sum function, and we see that the answer will still be 45. So there we have it for this section. Throughout this section, we have explored the practical application of control structures such as the if-else and select case statement, and also the power of loop structures like the for loops and the do loops in the realm of Excel VBA. Now remember, control structures allow us to make decisions and direct the flow of our macros, while loop structures enable us to automate repetitive tasks. By combining these techniques, we can create robust and efficient Excel VBA macros that enhance our productivity and unleash the full potential of Excel. Now here comes your first assignment. So you have this assignment that goes like this. You have a data set of temperatures in Celsius. Use an Excel VBA loop structure to convert these temperatures to Fahrenheit. The formula to convert Celsius to Fahrenheit is Celsius multiplied, which is the value in Celsius multiplied by 9/5 plus 32. Perform the calculation until an empty cell is encountered in column A. So this is the question and this is the data set. You have to convert Celsius to Fahrenheit. So you have to use one of the loop function. You can see the question. To make it easy, I just have to use that statement, use an Excel VBA loop structure. If I want to make it difficult, I won't even mention that. I will just tell you convert Celsius to Fahrenheit and this is the data set, do that. But I'm giving you an idea. Use an Excel VBA loop structure. So you either use the do while or the do until. I won't tell you which to use, but use a loop structure to do that. Which of the loop structure to use is left for you. I'm very sure you received the message I sent you when you enrolled in this course. So my email address is there. You can go back to that message to get my email address and send your assignment to me. Okay, so I have also included my email address so that those who may not find that message again won't start searching. So this is my email address. Send the answer to my email address. I already have the answer. So if your answer is wrong, I will return your email by sending you the answer, the VBA code and everything for you to run it yourself. So what I need is just the VBA code to this question. So this is the data set. You can send it as a text document file. So you know how to create a text document file. This is an example of a text document file. So you can just go there, go to new, then go to text document file. So if you open it, it gives you the space to input your code. So here we have it. So you can just paste the VBA code here. It's very easy. You can see what I did there. So this is how the code look like. Then you save it and send me this particular code. So I will go through it. If it is wrong, I will return the email with the right answer. If it is correct, I will let you know that it is correct. All right. So I look forward to your assignment. Now that you have a solid understanding of control structures, let's move on to loop structures. What is loop? Loop allows us to repeat a set of instructions multiple times, making them perfect for automating repetitive tasks. One popular loop structure is the for loop. What is the for loop? The for loop is a widely used loop structure in Excel VBA. It allows you to specify the number of repetitions and increments through a range of values. This is particularly used when you need to perform an action a fixed number of times. Remember the example we did when we used a VBA code to split those worksheets into separate files. We used the for each loop in our procedure. So the for loop is a widely used loop structure in Excel VBA. It can be used in different ways. The for each loop that we use in that VBA procedure to split Excel worksheet into separate files is a type of for loop. I have also used the for loop in other lessons. If you have been following me, you can go back and check to really understand the use of the for loop. Now, in this lesson, I want to just show you how you can also use the for loop or the for each loop to protect worksheet in Excel. So this is our Excel worksheet, and normally if you want to protect your worksheet in Excel, you can just do it the normal way, which is this one here. You right click, you go to protect sheet, then you input a password. Let's just say 2356. Then you click OK, and you are asked to repeat the password again, which is 2356. Then you click OK. Automatically your worksheet will be locked. Okay, you can see we have logged this worksheet. If we try to input anything into this worksheet, it will give this prompt, which means the worksheet is protected. So you can't do anything unless you enter the password. So we can use VBA to also do this same thing. So this one is free because we didn't lock it. So you can lock each of them as you want. You see protect sheet, you put the password there. You can put different password for the different worksheet. Now let me show you how you can use VBA code to lock this 3 sheet with just one password. And if you observe, when I enter this worksheet in particular, this ribbon tab, you can see none of them are active here because they've been locked. But if you go to the next sheet, you can see that they are all active. You can see it showing here, and next one the same thing. But if you go back to this one here, you can see we can't do anything. So we have to unprotect it, which is you right click, go to unprotect, enter the password again, then the sheet will be unprotected. You can see the sheet is not free. So you can use the for loop to lock your worksheet in Excel instead of using the normal way I just showed you. So let's go to developer tab and go to our Visual Basic Editor. Alright, so I already have the code here. You can, this is my code, but I have not activated it. That is why it is free. So let me explain it for you. This is how you can write the code. Now this is the title of the procedure, then dim ws as worksheet, and I want to lock each worksheet. So for each worksheet in this workbook, which is the one that the VBA is affecting, dot sheet, remember dot sheet stands for all the worksheet in the workbook. Now this is how you protect a worksheet. You just say worksheet, which is ws.protect. So if you want to protect the entire workbook, you can say this workbook.protect. So you get it. So worksheet.protect, then the password, you just state the password here. Now this is an integer, so you don't use the double quote. If I was to use letter, I will have to use the double quote, like do something like this. So I just type amen, then I also close double quote if you want to do that. But I prefer to use integer, which is 2356. Our password. This is our password, and use the next. Next means it goes to the next sheet and the next sheet and the next sheet until it gets to the last sheet. Then it ends the sub. Remember, this is a for loop. Remember, we are looping. It is repeating the same task for other worksheets. So that is the next. So this is the for each, and this is the next, which is also a type of the for loop. So for each, we have the for each, and we have for next. These are also types of loop. So I'm just teaching you how you can use them in different ways. So this is the for each. I'm very sure you understand. I explained this. So let's just run our code. Okay. Now just click on this, and okay, it is done. Let's now go back to our worksheet here. Let's go to the home. That tells us if it's locked. Okay, you can see they are all locked. Alright, so let's start from 2020. Let me try to input something. Okay, you can see that. Let's go to the next one. You can see the same thing. To the next one, you can see the same thing. So the three worksheets are locked by one code. So to unlock it, that person needs to enter the password, which is just go to unprotect. The password is 2356. Hit the enter button. This opens this particular worksheet. You can see right now it is free. I can type something inside. Alright, the next one, the same thing. You have to enter the password. So this is how you can use VBA code or for loop in particular to lock the worksheet in Excel. Now if you want this thing to work, let's assume you want to save it as locked. All you need to do is to save the new change. Now to enable your worksheet to be saved as a macro workbook, you can't use the normal Control S. What you need to do is to go to File, then you go to Save As. Okay, you can see right now, you see Excel macro enabled workbook. If you don't choose that extension, it won't work. Normally it's always Excel workbook, or you just go to this CSV part, but you have to enable that workbook. So you have to pick the extension Excel macro enabled. This way, any changes you make in your worksheet and you save that worksheet, it follows. But if you don't do that, it won't save as an Excel macro enabled workbook. In case you are trying to follow me and it is not working for you, maybe you saved the file but it did not save as you want it, make sure you save it as an Excel macro enabled workbook. That way, if we close this file and send it as an email to someone, the person needs to get that password to be able to alter the data in the worksheet. You get it? So once again, this is the code. Very easy, just simple and straightforward. This is how you can lock Excel worksheet using VBA code and using the for each loop or the for loop. In this lesson, we will explore the fundamental concept of variables, their importance, and how they are used in Excel VBA. Variables are placeholders used to store and manipulate data in computer programs. They act as containers that hold values such as numbers, text, date, or object during the execution of a program. VBA supports several data types that can be used to declare variables. Variable types generally fall into two categories, which are the numeric and the non-numeric variable types. The numeric variable type stores number-based data, while the non-numeric stores everything else. Now let's look at the numeric data types. The first one, we have the byte. The byte stores small positive numbers. We hardly use this when we're writing our VBA code because we mostly do with bigger numbers, which leads us to number two, which is integer. This is one of the most commonly used numeric data types. Integer stores numbers that won't have a decimal. So in other words, integers are used to store whole numbers. Then the next one, we have long. Long is a longer form of byte. So instead of using byte, you can use long. Maybe you want to deal with a more bigger positive numbers. But long is a longer form of byte. Then we have the single. Single stores number that may have decimal. So if you are working with value that may have decimal, then you can use single. Then we now go to double. Double is a longer form of single. They can store very large negative or positive range with high precision, and also they can also be used for percentage. So that is what we can use double for. Then lastly, we have the currency. This is mostly when you are dealing with values that has to do with currency. So these are for exact calculations. Now, what about the non-numeric data types? We have the string. I'm very sure you are conversant with that because we have been using it from the start. So string is used to store text. And we have the boolean. Boolean stores binary results like true or false, yes or no. And we have the date. This is used to store date and time. Then we have object. Object stores object addresses like range, cells, and every other stuff that has to do with object. Then we now have the variant. Variant is a special data type that can hold any type of data. Unlike other data types that have special format, for example, integer for whole numbers, string for text, variant data type is versatile and can adapt to store different types of values. When you declare a variable as a variant, you don't need to specify its data type. VBA will automatically determine the data type of the value being assigned to the variable at runtime. This flexibility makes the variant a convenient choice when you need a single variable to handle different data types, or when the exact data type of the value is unknown or can change during the program execution. If you look at the screen right now, we declare var as variant. As far we have done this, we can assign any value to var. We can say var is equals to 42, which is an integer. We can also say var is equals to hello, which is a string. We can say var is equals to true, which is a boolean. Remember I said boolean has to do with yes or no or true or false. We can also say var is equals to range, which can be object value. So when you declare a variable as variant, you don't need to specify its data type. VBA will automatically determine the data type of the value being assigned to the variable at runtime. However, it is essential to use it judiciously and consider declaring data types whenever possible to ensure code reliability and efficiency. And it is also important to use the right variable types, because if we store data as an integer, for example, and let's say we store the number 9, and later in our code, if we divide that variable by 2, which will result in the value 4.5, the decimal won't actually be stored into the system because it is expecting an integer type of value, which should be a whole number. At the end of the day, this produces error and inaccuracy into our calculations. So it is important to pay attention to our variable types. Always know in advance the value that will be assigned to any variable that you are declaring, either as a variant or as an integer or as a string. Now let's say I want to declare variables and these variables should be integer. The easiest way I can do this is to declare a different variable on every single line. So I can say dim age as integer. I can go to the next line and say sum age as integer. Then I can also go to the next one and say dim sum total as integer. Now this is a valid VBA code. There is nothing technically wrong here, but as we can see, this takes up quite a bit of space. It takes up 3 lines of code. What we can actually do is to simplify this a little bit by writing our code like this. So we just say dim age as integer, then we include a comma, sum age as integer, include another comma, then sum total as integer. This way we can place multiple variable declarations on the very same line. There is a common mistake that beginners make whenever they are trying to emulate this syntax in their code. They write something like this: dim age, then include a comma, sum age, include a comma, then sum total, then they will now end it as integer. This is very wrong. This is a little bit deceptive because you would think that VBA would figure out that we want all 3 of these variables to serve as integers. But what is actually going to happen here is that only sum total is going to be declared as integer type, because age here, age and sum age are not given explicit data types. They are going to assume a data type of a variant. Only sum total will be declared as an integer. So when this two takes the data type of variant, it is not great in making your code efficient and quick as possible during execution. So it is very important you know how to write your variable. You either do it like this or you do it like this. Both of them are great, but this one here is very wrong. So if you see other people doing it, do not do it, because it does not make your code efficient and quick as possible during execution. Okay, so I just felt we need to do a calculation, and that has to do with variables and loops. Now you have a data set containing the names and ages of 5 people in an Excel worksheet, which we have there. This is the name and the ages of those 5 people. Now the question goes like this: using VBA, write a program to calculate and display the average age of these 5 people. So we want to write a program that will calculate and display the average age of these 5 people. So it is very easy, but I want you to go with me. I want you to follow me step by step. I won't paste any code. I want to write from scratch as I explain everything. First thing first, we write our sub. Then we are calculating for average age. So we just say calculate average age. Alright, we hit the enter button, then that shows up. The next thing we have to do is to declare variables. Now, how do you know which variables to declare? I believe that is a very nice question that you may be asking in your mind. How do I know which variables to declare if I'm to write a program? You can get it from the question or from what you want to achieve. That is just the answer. To know the variable you have to declare, you can get it from the question or from what you want to achieve. In this case, we are asked to calculate the average age of the students. Now, the formula to calculate average age is sum of age divided by the number of people, which is the total age divided by the number of people. This means we will need 3 variables, which is the total age, the number of people, and the average age, which is what we are looking for. I don't know if this is clear. So let's declare our variables. So the first one is dim total age as integer. Then we declare the second variable, which is the number of people. So we can just say num people as integer. Then our last variable, we can say dim average age, is what we are looking for, as double. So why do we use double? Remember in our previous video I said double is the longer form of single, and single stores numbers that may have decimal. Remember, this has to do with division, and we don't know if our answer will be in decimal or not, so it is safe for us to use double. We might not get a whole number in our as our result, and we may get a whole number as a result, but we don't want to encounter any error, so we just use the data type double, because double can store higher number of values with decimal, and it can also store both negative and positive result. So that is why we are using double there. Now the next thing we have to do is to assign the variable. So total age is equal to 0, because we don't know that right now. Then the number of people in our data set, that should be 5. Yes, we have 5. 1, 2, 3, 4, 5. So the number of people is equal to 5. Now, because we are running a calculation that moves from one cell to another, we will need to apply loop in our code. Remember, we are looking for the average age of each student. So we are moving from each student. So we are looping from one cell to another cell to another cell. So this means we have to apply loop in our code. The loop will run through the range containing ages and calculate the sum. So for that, we use the for loop for I is equals to 2 to 6. This means the loop will run from row 2 to row 6. Is what we have here, row 2 to row 6. That is what it means here. Now, the I that I wrote there is a loop variable used in the for loop. It is a temporary variable that takes on different values in each iteration of the loop. I is used to represent the row number of the cells in the Excel worksheet that contains the age. So we just use the I there. So I stands for any number in the age column. During each iteration of the loop, I will take the values from 2 to 6, and the code inside the loop will be executed. In this case, the code inside the loop calculates the sum of ages by accessing the cell in column 2, which is the age column, for each row, and add it to the total age variable. And here is the formula we are giving to VBA in this code, which is total age equal to total age plus cells, and open a bracket, I comma 2 close the bracket dot value. Now what does this mean? The cells I comma 2 here, this refers to a specific cell in the Excel worksheet where I represent the row number and 2 represent the column number. Remember, we are looping, so we are not using a fixed number. So I stand as a loop variable, and during each iteration of the loop, it takes the value from row 2 and takes it down to 6 in the active Excel worksheet. Why this dot value here? This properties retrieves the value contained in the specified cell. So this one goes with this. So whatever value we have here is what appears here. So we don't have a specific number. So it goes from here. So at a time it will take on 25, at another time 30. It continues going like that and start adding everything all together. So that is why we have this statement here. By the end of the loop, the total age will contain the sum of all the ages in the data set, which will then be used to calculate the average age. So I'm very sure this is clear. Total age equals to total age plus whatsoever specific value that is in that particular cell at the particular time when the loop is running. Okay, so then we now use the next I, which is continue from 2 to 6. Remember, I there runs from 2 to 6. So when it's done with 2, it moves to the next one, which is 3, 4, till it gets to 6. Now, to calculate the average age, we have to give the VBA engine the formula to use, which is average age is equals to, remember I said the formula for average age is total age divided by the number of people. So that's total age divided by num people. So that's the number of people. So that is the formula. And remember, we're asked to display the result in a message box. So we just use message box, then a double quote. I want the message box to have a message, so I just want to repeat the message. All right, the average age of the 5 students is, then I will include double quotes, and the average age. The and here, this and statement or the and operator is used to join the message with the value stored in the average age variable. So whatever answer we have as the average age is what will be displayed here. That is why we have it here. Alright, so this is just the VBA procedure we can use to calculate the average age of the student in this particular worksheet. Alright, so we are done with our code. Yes, we are done with our code. I'm very sure this is very easy for you. If you don't understand, you can replay this video over and over again till you get your understanding. And aside that, you can always ask me questions. Remember, you have my email address. You can always message me and ask me any question that you would like to get clear on. Okay, so let's run our code and see the answer we are going to get, if it is decimal or it will be whole number at the end of the day. Okay, so our answer is 28. You can see the average age of the 5 students is 28. So that is our answer. Okay, so there you have it for this particular lesson. And I'm very sure this exercise was really challenging and very exciting for you. So you can write it by yourself again. You can choose to change the figures and see if you will still get a good answer. So just follow the same script, change the figures or include more names to this worksheet and run it yourself and see what you are going to get. This is how you learn. You don't just learn by watching video, you learn by practicing. So you can see the code on the screen, you can see the data set on the screen. You can just create your own data set, then follow what I did. I explain every step. I explain why I use 3 variables here, because these are the 3 variables that we are going to work with. So that's why I declared 3 variables here. We are looking for the average age, and the average age has a formula, which is the total age divided by the number of people, which means we are using 3 variables here, names here, or 3 statements. So we have to use the total age, number of people, and the average age as our variable. Yes, integer here, yes, whole number of people is whole number, but average age we don't know if it will have decimal or whole number, so we have to use double just in case it comes out as decimal value, because it has to do with division, and most times our division might land us with decimal value. Then total age is 0, we don't know that. Number of people in the data set is 5, so that we have 5 here. Then we are going to loop because we are going from cells to cells, so it involves looping. So for I, the I there is a loop variable used in the for loop, which stands to represent the value from row 2 to row 6. So I here is declared as a loop variable that will run from 2 to 6, which is from row 2 to row 6. Then the formula we are giving to the code is total age equals to total age plus cells, which is cells. The I there stand for the row, while the 2 there stand for the column. Remember, our age is in the second column. Dot value stands for whatsoever number is in that specific cell when it is running. So at first it will start with 25, then goes to row 3, comma 30, then 4, comma, like that it goes. So the I stand for all of them from 2 to 6. Then the next I, which is continue to the next number. Then we gave the VBA engine the formula we want it to use to get our answer, which is average age equals to total age divided by the number of people, and we want that answer to be displayed in the message box. So here we have it, message box. I want this message to appear, which is the average age of the 5 students is. Then I wrote this stands for any answer it gives us will appear here. The and, like I said, the and operator is used to join the message, which is this message here, and the final answer we will get. So that is it for this video. I'm very sure this is clear to you. Just try to practice it as much as you can to get really understanding. Alright, see you in the next lesson. In this lesson, we will explore techniques to handle runtime errors and master the art of using debugging tools in the VBA editor to find and fix issues. If you are writing VBA code, error is something you will have to deal with. Error handling and debugging are essential skills for any programmer, as they help identify and resolve problems in code efficiently. Why error handling? Runtime errors can occur due to various reasons, such as invalid inputs, unexpected behavior, or external factors. Without proper error handling, these runtime errors can lead to program crashes and unreliable applications. The main goal of error handling is to anticipate potential issues and provide a fallback plan when something goes wrong. There are three types of errors in VBA. We have the syntax error, which is detected by the VBA editor during code compilation. We have the runtime error, which occur during code execution when unexpected conditions arises. And we have the logical errors. This is where no errors are displayed but the code does not work as intended. So these are the three types of errors in VBA. Now, before we dive into error handling techniques, let's explore some common runtime errors. The first one we will cover is division by zero. This error occurs when attempting to divide a number by 0. Let's see an example. In this example, we are trying to divide 10 by 0, which is not allowed in mathematics and programming. When the code executes this line, a runtime error 11 division by 0 will occur. I will be using my F8 for this lesson so that you can see where the error occurs. So the execution will start from the beginning, and when it gets to that point where we have 10 divided by 0, it's going to display an error notification. So let's see for ourselves. Okay, step into, and we step into, you can see. Then from here, an error will occur. You can see runtime error 11 division by 0. So, and if we try to debug, it will tell us the line where we have the error. So it won't go further than this because an error has occurred. Now there is a way we can bypass this error. Yes, there's a way we can bypass it, whereby it will ignore the error and continue execution. One way is using the on error resume next. So what we need to do, let's stop this execution. Then we'll go here on error resume next. So we'll just type it here on error resume next. What this does is that it will skip the error and continue execution. That's just it. So when we include this into our code, it will skip that error and continue execution, whereby it will skip this 10 divided by 0 and go to the next one and still give us the answer. So it will ignore any error in your code. So let's run it again so we can see for ourselves. F8, okay, we move. You can see that ignore that first error and move, then we'll get our answer. The answer is 5. 10 divided by 2 is 5. You can see the result is 5. So that is how you can handle error in Excel VBA. Although I have something to say about this method, but I will say it at the end of this lesson, so just follow me. Let's go to the next error. Number 2, we have the null reference. This type of error occurs when trying to access a property or method of an object that does not exist or is set to nothing. Let's see an example. In this example, we created an object, which is my object, as object, but we set it to nothing, meaning it does not refer to any object. When we try to access the property, which is some property, a runtime error 91 will occur. Now here we are trying to access a property called some property. It will trigger an error because we are referencing something that does not exist, because we set my object to nothing. So this is what is going to happen when we try to execute this. You can see when VBA can find any property called some property, it triggers the error. You can see runtime error 91, object variable or with block variable not set. When you see this kind of error, just know that you are referencing something that does not exist. And if you try to debug it, it will tell you the line where the problem is. This is what we call the non-reference error. To handle this error, we can use the on error goto. So to do that, all we just need to do is to come over here and input it here on error goto. Then you can insert a label there, any name that you want to use, you can insert it there. I want to use error handler. Then you come here also and insert the word exit sub. Then for error handler, let's put it here, error handler. So this is the notification that we will get when an error is being triggered, and it will tell us where the error is coming from. So message box is what we want to tell us an error occurred. So we use this. Alright, so let me explain. So here we use the on error go to error handler. You can use any label here. I just want to use error handler to specify that if an error occurs, the code execution should jump to this error handler label. So anywhere there's an error, when it occurs, it just triggers and go to this place without completing the execution. So if my object is set to nothing, which is what we have here, attempting to access its property, some property which does not exist, will raise an error, and the code execution will immediately from here jump to this part. So it will exit the subroutine and jump to this place and display this message for us. In the error handler section, we display a message box which states that the error has occurred with an error description, which is error.description. We use the error.description. Then the exit sub here is used to exit the subroutine after handling the error. So the code following the error handling section would not be executed in the case of an error. So this one is more professional because when an error occurs, it tells you that an error has occurred. So let's execute it and see what's going to happen. So let's use the F8. We'll go. Okay, you can see it. Alright, let's continue. From there, you can see it has entered that message, then it will tell us the message. An error occurred, object variable or with block variable not set. So you can easily tell where this is coming from. Then end the sub, you can see it there. So this is one way we can handle error in our VBA code. Not specifically for non-reference error kind of error. We can use one specific error handling method to handle multiple errors. This method is not only for non-reference. We will see other examples so that we can understand it better. Number 3, we have the type mismatch. This occurs when attempting to perform an operation on incompatible data types. In this example, we declare the variable, which is deem my number as an integer, but try to assign a string value, which is hello. This will cause a runtime error 13 type mismatch because we cannot assign a string value to an integer variable. So for example, you created a form using VBA code, and where a user is supposed to input his or her phone number, he or she is inputting his name or her name there. So this will trigger an error because you can't input a string where a whole number is supposed to appear. You can see my number is being declared as a variable there, and right now where you are supposed to put my number, the person is putting a name or whatever text or string in that particular place of an integer. So it will trigger an error, which we are going to see right now. Okay, you can see runtime error 13 type mismatch. So when you see the word type mismatch, it means there's a displace of variable in the code, which means you have to look for where maybe where you are supposed to use integer, you are using string, where you are supposed to use string, you are using integer, just like that, or double. So that is the error you will see when there is a type mismatch. If you debug, you will see where the problem is coming from. Okay, so now how can we also handle this type of error, kind of like a mismatch error? We can also use the on error go to. Yes, we can also use it to handle this kind of error. So what we just need to do is to come over here on error go to, then let's just give it a name, let's give it a label, let's say error note. Okay, let's call it error note. Then we come over here and say error note, the message we want to appear, so message box, then let's just say invalid input. So this tells the person that the input made is invalid, please enter a valid number. Then we exit subroutine. Okay, so this is the kind of error handling you should use when you're writing a code, maybe when you are creating a form, a data entry form. So because Users wouldn't really know what is happening. They will just see an error message and be like, what is happening here? So they won't really understand what is wrong. As a professional, when you use such thing like this, it tells that user that okay, this is the error you are making and this is how you should correct it. So if we run this code, we are going to see how it's going to appear to that user. Okay, so you can see invalid input, please enter a valid number. So if that user there inserted a text, which is a name or any address, something like that, in the place of a number, that person knows that okay, I made a mistake, I'm supposed to enter a number. Because the end user won't understand those runtime error 91 and others. But when you input something like this, that tells that user that okay, this is where I'm making the mistake. It kind of like pass the message to a layman that does not understand VBA or even know anything about coding. I don't know if you get the point. So this is how you can handle error in VBA professionally. Let me just use the word professionally. So this is how you can handle it. So you give the on error go to, then you state the message there. That helps the user understand where the error is coming from. You as the VBA programmer, you know everything, but that end user does not know anything. And remember, you are creating an application for the end users who does not know anything about coding or programming. So this is how you can handle error in your application. Okay, let's go to the next one. So number 4, we have the out of range error. This occurs when accessing an array element, collection item, or any index object with an invalid index. As usual, let's go to our spreadsheet and see for ourselves. Here in this example, we have an array, which is my array, with 3 elements, indices 1 to 3 as integer. Now, when we try to access the elements with index 4, which is what we have here, which is behind the arrays band, a runtime error 9 will occur. So if we try to execute that, we'll get this runtime error 9, subscript out of range. Because why? We have only 1 to 3 as our array, yet we are trying to index 4, and that is out of range. That is why we have that out of range error, runtime error 9, subscript out of range. Now, how do we handle this kind of error? I know you may be thinking I want to bring a new error handling method. No, we are still using the on error go to. Don't worry, at the end of this class, I will tell you why I am always using that. So just stay with me. Now we can use the on error resume next, but there's a reason why I'm trying to avoid that. So we're going to use the on error go to. So let me show you. We just include it here on error go to. Let's just call it error handler. We use the on error go to 0. So I will explain. Just follow me. Error go to 0. Then we include the exit sub. Then we type the error handler message box and error code. Then we just state the error description. Okay, then after that we also use the on error go to 0 again before we end the sub. Okay, so let me explain first. We use the on error go to handler to specify that if an error which is out of range, if an out of range error occurs, the code execution should jump to the error handler label, which is what we have here. Then in the error handler section, we display a message box with the error description using the error.description. Now, I know you will be thinking, what about this on error go to? So after handling the error, we reset the handling to a default behavior using this on error go to 0. So that is the purpose of this on error go to 0. You can choose to ignore it and you can choose to include it. On error go to 0, the purpose is it helps you reset the error handling to the default behavior. So you can choose to use only on error go to 0. So this will just show 0 as the output error. Although this does not really have any big effect on the code, but professionally it is great you use it like this, but you can choose to ignore it. So let's just run our code, stop talking too much. Let's see what is going to happen. Okay, all right, okay, then it goes an error called subscript out of range. So if we continue, it goes and executes and finish. So this is how you can handle the out of range error in your code. Let's go to the last one. And the last one is the file not found error. I'm very sure you have an idea of what this is going to be. This type of error occurs when attempting to open or access a file that does not exist in the specified location. In this example, we are trying to open a file at the specific path, but it does not exist. You can see nothing like this exists in my computer. So when the code executes the open statement, which is open file for input as 1, a runtime error 53 file not found will occur. So if we run this, you can see it's trying to fetch that file from that file path. So when you now tell VBA to open that file in that specific path and VBA can't find it, it gives you this runtime error 53 file not found. You can see that kind of error. So when a user is trying to access a file that is not found in a specific part, it will show that user that error. Now, how can you undo the file not found error? This one is very let's say very technical or very specific for the professionals. So this is how you can handle it. We use the on error go to label, but there are other things that we still need to do to really handle it professionally. So this is what is going to happen. So let's end the execution. You come here, we type the on error go to let's use error notes. Then there's a new one. We now say if dir arrow, which is directory file path, is equal to an empty string, then gives us a message, which in a message box telling us that file not found and file path. Okay, then we exit subroutine. Then we end with end if. End if, then if that file exists, we can open it. Let's come here, then on error go to 0, which takes it back to the default behavior. So if that file exists, then open it, take it back to our default behavior, then we exit sub also. Remember, we have not typed our error note handler message. So then let's type our error note message. Okay, error note, then message and error occurred, then the error description message, then on error 0. All right, so this is the way you can handle this error. So let me explain properly. This is a final found example. Then we declared a file path as string, then file path is equals to this here, which does not exist. Then to handle it, we use the on error go to. So we can impute that on error go to, then error message. So we are using the on error go to label to specify that if an error occurs, the code execution should jump to the error note here. But before attempting to open the file, we check if that file exists. So if that's why we now use this statement here. If dir arrow file path returns an empty string, which is this here, it means the file does not exist and we display a file not found. So if this file path return an empty string, then we display the file not found message to the user. We then exit to prevent further execution. So we exit the sub to prevent further execution. And if the file exists, we proceed with opening the file. You can see what we have here. If the file exists, then we can proceed with opening the file using the open statement and perform any operations you need to perform with the file. Then after working with the file, we reset the error handling to the default behavior using the on error go to 0. Then the exit sub statement is used to exit the subroutine after handling the error or successfully working with the file. ensuring the code after the error handling section would not be executed in either case. Using the on error go tool with a specific error handling label and checking for the files existent with the DI arrow here allows you to handle the file not found error gracefully and provide meaningful feedback to the user when they try to access a non-existent file. So let's run this code and see for ourselves. It's okay, the F8, okay, you can see it's going. If that file returns an empty string, you should give us that message, file not found. You can see file not found. So that particular file path does not exist. Then we click the OK, then we continue again, end. You can see it end the execution of the code. You have seen for yourself, it does not continue. But assuming that file existed, it will continue running till it get to this point. But as far that file does not exist, we exit the subroutine. Let's do it again so you can see it. Okay, if file is equals to an empty string, then display this message, and it just did. If you continue, exit sub, we continue again, we are done with it. That is how you can handle a file not found error in VBA. It's very easy to understand. I've already explained everything for you. So there we have it for this lesson. I'm very sure you really understood what I have showed you in this lesson. So like I said earlier in this lesson, avoid using the on error resume next. While it might seem like a quick fix, using on error resume next could hide other potential errors in your code. Because what it does is it ignores the error in your code and continue execution, and this is not really good because in the future time it may really create problems. So while it may seem like a quick fix, using on error resume next could hide other potential errors in your code. So I will advise that you avoid using that on error resume next. I just have to show you so you can know that something like that exists. Instead, use proper handling techniques like on error go to or on error go to 0 to gracefully handle errors. Using on error go to with a specific error handling label allows you to handle errors more precisely and provide better feedback to the user when issues arises during runtime. So as a developer, you should ensure that you include error handling techniques into your code, because a good developer must ensure that error handling is done properly. Users should not get a bug. What they should get is a prompt to let them know what they are doing wrongly. Alright, so thank you for your time and thank you for enrolling in this course. Please, if you have not still dropped a review for this course, please go and do that. It means a lot to me. So go and review the course, go and rate the course, drop your review. Just be sincere with me. If you love this course, if it's a good investment for your money, please let me know in the review section. Just do something there. Rate my course, whatever rating that you want to give to it. If you feel it is worth 5-star, give it 5-star. If you feel it is worth 3-star, no problem. But drop a reason why you are rating it 5-star or why you are rating it 1-star or 3-star. Alright? Thank you for your time. Here is another assignment for you. You have a data set containing the names and scores of 5 students. Using Excel VBA, write a program to find and display the highest score among these 5 students. And here is the data set that you are going to use. These are the names and the scores of the 5 students. So you are going to write a program that will go through these scores and find the highest score among these 5 students. So when you are done with the answer, you just send it to my email address. And don't be scared. Even if you don't have an idea, just do what you can and send it to me. I will send the answer to you if you get it wrong. Very simple. So if I go through your work and find out that you get it wrong, I will reply that email and send back the answer to you so you can run it yourself and know where you went wrong so you can make corrections. All right, I look forward to your assignment.